Hi everybody, it's Mrs. Mancuso. Want to go through another chemistry Regents exam with you. Today we're going to do the August 2016 exam. So let's get started. What change occurs when an atom in an excited state returns to the ground state? So when it goes back to ground state, it's going from out here, if this is my nucleus, out here, and it's going back to an orbital that is closer to the nucleus. So that would release energy. So energy being emitted is energy being released. The valence electrons in an atom of phosphorus in the ground state are all found in. So grab your reference table. Phosphorus is element P. It has 2-8-5. So those 5 valence electrons are in the third shell. Which two elements have the most similar properties? If they have similar properties, they must be in the same group. So beryllium and magnesium, there we go. Those are both group 2. Which phrase describes a compound that consists of 2 elements? So it's not a mixture. Compounds aren't mixtures. They are pure substances. So a substance in which the elements are combined chemically in a variable proportion. No, it's not variable. It's fixed. So compounds chemically combined in a fixed proportion. The formula mass is well, you don't multiply it, you add them together. So it's the sum of the atomic masses of its atoms. Yep, it's the mass, not the atomic number. Whoops. All right, let's get back on track here. Number 6, the arrangement of the elements from left to right in period 4. So that means I'm going across period 4. That is based on the atomic number. It just goes right over in number order. Which diatomic molecule is formed when 2 atoms share 6 electrons? So sharing 6 electrons is 1, 2, 3, 4, 5, 6. It's a triple bond. So nitrogen forms a triple bond. Actually, let me just grab a new page and show you that. A hydrogen with a hydrogen is just 2 electrons being shared, so that's a single. Oxygen has 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This has 1, 2 bonds forming. So oxygen looks like that. Nitrogen has 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when you loop the lonelies, you form a triple bond. So that's why there are 3 shared. All right, next one. Which one is a polar molecule? So a molecule means I want to look at, is it symmetrical or not? And O with an O is completely nonpolar, no pulling. CO2 is going to look like this. Sorry, this is an O. So that's very even and symmetrical, so that's very nonpolar. Ooh, there's my answer. NH3. An N with 3 H's. You know from those 3, that number 3, it's going to be odd. So that is a polar molecule because it's asymmetrical. A C with 4 H's around it is going to be very symmetrical and balanced. All right, which element is least likely to undergo a chemical reaction? So if it is least likely to undergo a chemical reaction, that's because it's a noble gas. It's already perfect. It has full valence, so that's neon. Which element has a melting point higher than the melting point of rhenium? So I got to look up rhenium and see what its melting point is. So I go here on table S, and first of all, I got to find it. So, rhenium, where are you? Don't even see it yet. All right, I found it. It's number 75. So the melting point is 3458. So I just want to write that down quick. 3458. That's the melting point of rhenium. And I want one that is higher than that. So I look up iridium, and it is 2719. So that's not going to be a choice. Osmium is 3306, so that's lower. Tantalum is 3290, that's lower. Tungsten is 3695. There we go. That's going to be my answer. 11. Which property can be defined as the ability of a substance to be hammered into sheets? If you can hammer it, it's malleable. So metals have that property of malleability. Which list consists of a metal, a metalloid, and a noble gas? So aluminum, that's a metal. Sulfur, that's non-metal, so not that one. Magnesium's a metal. Sodium is a metal. Nope. Sodium's a metal. Silicon is a metalloid because it's got two sides touching the staircase, and argon is a noble gas. There's my choice. Which sample has a crystalline structure? If it's a crystal, it's got to be a solid. So I'm going to choose choice 3 because it was a solid. 1 mole of liquid water and 1 mole of solid water have different. All right, well, they definitely have different densities, but that's not a problem here. So the gram formula mass is going to be exactly the same because they're both H2O. The empirical formula is H2O. Oh, the properties are going to be different. A solid is going to float, and a liquid is going to have its molecules move past each other. All right, which substance cannot be broken down? If you can't break it down, it's got to be an element. So go look at the periodic table. Gold is on the periodic table. Which statement describes particles of an ideal gas? So ideal gas want to spread out. So they don't move in predictable, whoops, I don't know why I did that. They do not move in predictable things. Oh, here it is. They have no attraction between them. Gases spread out because there's no attractions. All right. Which expression could represent the concentration of a solution? So how concentrated something is, go look at table T. Molarity expresses concentration. Which form of energy is associated with the random motion? Molecules moving, that's kinetic energy. So that's not chemical, that's not electrical, it's not nuclear. Ooh, that's related to temperature, which is related to heat, which is related to thermal energy. What change is most likely to occur when a molecule of H2 and I2 collide with the proper orientation and sufficient energy? So if I have H2s and I have I2s and they collide, I could have a chemical change and I could make HI. HI. So it is a chemical change and it's forming a compound because I have two different atoms in it in a fixed ratio. Which ones can reach dynamic equilibrium? So nuclear change, we usually don't think of nuclear changes as reaching equilibrium at all. They're changing elements. So no, no. Chemical changes can, but physical changes, you could go back and forth between a solid and a liquid, and that's equilibrium as well. So chemical and physical could undergo. All right, what occurs when a reaction reaches equilibrium? All right, I want to remind myself, I want the rates to be equal and the concentrations constant. So concentration increases, no. Concentration increases, no. Rate of the forward is equal to the rate of the reverse. There we go, there's my answer. Next one. In terms of potential energy, which expression describes the heat of the reaction? So delta H is always equal to the product energy minus the reactant energy. So products minus reactants. There it is. Systems in nature tend to undergo changes that result in. All right, just think of you by the end of the day. We are not going to have higher energy, we're going to have lower energy, and then entropy is going to increase. We're going to have more disorder. So things tend to go to states of lower energy and more disorder. What occurs when Cr plus 3 ions are reduced to Cr plus 2 ions? So if they're reduced, reduction is gaining. So electrons are gained, and the oil goes up and the rig goes down. So the oxidation number decreases. Where do reduction and oxidation occur? Well, reduction, red, cat, so that happens at the cathode, and ox, so that oxidation happens at the anode. So reduction at the end, no, reduction at the cathode, there it is. Which one is an electrolyte? So right away, I want to make sure I'm choosing an acid, a base, or an ionic salt. Water, no. C2H6 is a hydrocarbon, no. Ooh, there's an acid, H3PO4. I could look on table K, and that would be listed there. When the hydronium ion concentration of a solution is increased by a factor of 10, the pH. Okay, Down here are my H pluses, or hydronium means H3O plus. So this is down at 0. Over here at 14, this is where my OH minuses are the greatest. So if I increase it by a factor of 10, that means I'm going down the pH scale by 1 number. So it decreases by 1. So for example, if I went from a pH of 4 to a pH of 3, I would have 10 times more H pluses. The stability of isotopes is related to the ratio of, it's all about the neutrons and the protons. So elements over 82, elements over lead, have an imbalance in the protons and the neutrons in the nucleus, which is why they spontaneously decay. All right, which radioisotope has the fastest rate of decay? I need to go to table N and look it up. So, carbon 14, I'm just going to write them right next to it. All right, carbon 14 is 5,000 years. All right, that's really long. 37 calcium is a millisecond. This one right here I'm writing millisecond next to. And I am definitely crossing off carbon 14. Fe53 is in minutes, and 42K is in hours. So I definitely want choice 2. The one in milliseconds would decay the fastest. The atomic mass of an element is the weighted average of the atomic masses of. Well, I don't want the least abundant. I want the naturally occurring isotopes. I want all the naturally occurring isotopes of an element. I don't want artificial at all. All right, so that is the end of the first video. We will continue with the next video with the next part of this exam.